Good day and welcome to K Tutors. At K Tutors, we demystify your curiosity and we help you to enjoy maths. In the previous lesson, we started a series on decimal numbers. We said that decimal numbers are numbers that have decimal points in them. Like fractions, decimal numbers are part of a whole number. We looked at the place and the values of all the digits in a decimal number. And finally, we ordered decimal numbers in ascending and in descending order. So, if you are yet to watch that video, kindly click on the link above to watch the video. Today, our words for discussion is converting decimals to fractions and then fractions to decimal. So, if you are yet to subscribe to our channel, kindly do so and don't forget to turn on the notification bell so that you'll be one of the first persons to see our video once we publish it. So quickly, let us go into the classroom to demystify the concept of converting decimal numbers to fractions and then fractions to decimals. Let's convert decimals to fractions. Examples. Change the following decimals to fractions. Number 1, 0.16. Here, in order to convert 0.16 to decimal, you are expected to draw your division line. Under the decimal point here, you write 1. Then you look at how many digits do you have after the decimal point. There are 2 digits after the decimal point. So you're going to write 2 zeros because there are 2 numbers after the decimal point. And since 0 here signifies nothing, you strike it off. So what do we have here? We have 1600th. You cannot leave this like this, though you have converted to fractions. It is advisable to always reduce to the lowest term. And how can you reduce to the lowest term? You look for numbers that can go into the numerator and the denominator without remainder. So what number can divide 16 without remainder? 16 here is an even number. So 2 can divide 16 to give you 8, and 2 can divide 100 to give me 50. Okay, now you see 2 went into 16 and 2 went into 100. So I used 2 up and I used 2 down. I did not use 3 up and 2 down. I used 2 up and down. So whatever I use up, I must use down. So what else again can go into 8 and 50 without remainder? 8, I can divide 8 by 2 to give me 4, and as well I can divide 50 by 2 to give me 25. Why is 4 over 25 my final answer? 4 over 25 is my final answer because nothing can go into 4 and 25 at the same time without remainder except 1. So if we keep dividing the numerator and the denominator by 1, we'll keep getting the same number. For instance, 4 divided by 1 is 4 and 25 divided by 1 is 5. So we have succeeded in changing 0.16 to fraction, and the value of 0.16 in fraction is 4 over 25. Let's look at the next number. Number 2 is 9.4. 9.4 is different from 0.2 because here the whole number is 9 while the whole number here is 0. So in this case, you can also divide. Under the decimal point, you write 1, and under 4, you write 0. Why am I writing just 1 0? Because we have just 1 digit after the decimal point. So in this case, you are going to put your 9 in your cooler and divide only 4 over 10. So in this case, we have 9 whole number. You take this as a whole number. 4 over 10. So you can now reduce 4 and 10 here to the lowest term. 2 can go into 4 how many times? Twice. And 2 can go into 10 how many times? 5. So what's my final answer? My final answer is 9 whole number 2 over 5. Let's try number 3 together. Number 3, we have 2.008. Again, you're going to draw your dividing line and you have 1 underneath your decimal point. Under the 0, you write 0. Under the 0, you write 0. And under 8, you write 0. Why do I have 3 zeros here? Because I have 3 digits after my decimal point. Again, I'll write 2 whole number. You can do away with the 0. 8 over 1000. Now this is an even number. 1000 is an even number, so you reduce the both of them to the lowest term. 2 here is 4, and 2 into 1000 is 500. 4 is an even number. 500 is also an even number, so 2 can go into the both numbers. So we have 2 into 4 is 2, and 2 into 500 is 250. 250 is an even number, while 2 is also an even number. So 2 into 2 is 1, and 2 into 250 is 125. So what's our final answer? Our final answer is 1 over 125. So let's try number 4 together. Number 4 is 0.625. Okay, again, you draw your dividing line. Under the decimal point, you write 1, and under the 3 digits after the decimal point, you write 3 zeros. Why are we writing 3 zeros? Because we have 3 digits after the decimal point. So this, since 0 is nothing, I'll throw the 0 away, and I have 625 over 1000. Now, this is an odd number. Why is it an odd number? Because it's ending in 5. So 2 cannot go here, but 2 can go here. So 2 does not qualify. So let's move to another number. Can 3 go here? 3 cannot go here. So what about 5? Of course, 5 can go here because this number is ending in 5 and 1000 is ending in 0. So 5 into 625. 5 into 6 is 1, remainder 1. And 5 into 12 is 2, remainder 2. And 5 into 25 is 5. Then 5 into 1000 is 200. 5 into 125 is 25. And 5 into 200 is 40. Again, 5 into 25 is 5, and 5 into 40 is 8. So what's our final answer? Our final answer is 5/8, or 5 over 8. Now number 5, 1.725. This is very simple. As usual, I expect you to solve this and drop your answer in the comment section. Let's convert fractions to decimal. Earlier on, we converted decimals to fraction. Now let's convert fractions to decimals. There are 2 ways to solving this. The first method, this method is very simple, but is limited. You can only solve it for some fractions. Now, you look at these 2. The denominator 2. We're going to look for the equivalent fraction that will give us 10. So if I multiply 2 by 5, will I get 10? Yes, I'll get 10. And whatever I do to the denominator, I must do to the numerator. So I will also multiply 1 times 5, and that will give me 5. Now, 10, 5 divided by 10. Remember what we discussed in our last class. If you are dividing by 1 with 0, what you do, you just move the point depending on the number of zeros you have. So in this case, I have just 1 0. So I'll move my point just once backward and I'll hold my point with a 0. So here I have 0.5 as my final answer. Let us look at another example. Here we have 25. What can I multiply by 25 to give me 100? I can multiply 25 by 4. And whatever I do to the denominator, I'll also do to the numerator. So here I have 12 over 100. So I have 2 zeros here. So I have a point here. And my point to move, remember you have to go between the numbers 1 and 2. Once again, why am I moving twice? Because I have 2 zeros. So I replace here with 0. And what's my final answer? My final answer is 0.12. Let's look at the last one here. This is very simple too. What will I multiply with 5 to give me 10? Let's look at this. It can either be 10, 100, 1,000, 10,000, and so on. And remember, what you do to the denominator, you must do to the numerator. So 5 is closest to 10. So I will multiply 5 by 2 to give me 10. I can as well multiply it by 20 to give me 100. So 5 times 20 is what? 100, and 4 times 20 is 80. So this is 80 all over 100. So my point is here, right? I'll move my point twice, 1 between and 2 because I have 2 zeros here. And what's my final answer? My final answer is 0.8. If you wish to put your 0, fine. Quickly, let us look at method 2. But before we look at method 2, we can as well say 4 over 5. Here, let's multiply this by 2 to give me 10. The trick here is whatever you do to the denominator, you also do to the numerator. So here, this will be 8 over 10. My point is here. I have just 1 0 here. I'll move 1s to the back. And here I have 0.8. Okay, so let us solve method 2. Here, it is not possible to get a whole number to multiply 6 by to give you any of this multiple of 10. So what you will do is to use the long division method. And how can I use the long division method? Is to put 5, the numerator goes inside and the denominator is outside. Can 6 go into 5? Not possible. So I'll write 0 and put my point. As I am writing my point, I am adding 0 to 5 and this becomes 50. 6 into 50 is 8. 8 times 6 is 48. I'll subtract and I'll get what? 2. Now, since I already have my decimal point here, there is no need to put another decimal point because a decimal number has only 1 point. So since I have my decimal point here, all I need to do is to add another 0. 6 into 20 is 3. 3 times 6 is 18. I'll subtract again and that I'll get 2. 6 into 2 is not possible, but I have my decimal point written here already, so I'll just add my 0 here. 6 into 20 is 3. 3 times 6, I'll get 18. So in this case, I'll have what we call reoccurring decimal. So at this point, I can round off to the nearest 2 or 3 decimal places. but I'll prefer to round off to the nearest 2 decimal places. At K-Tutors, we have learned how to round off numbers to the nearest whole numbers, to the nearest decimal places, to the nearest significant figures. So if you are yet to watch that video, click the link here to help you understand how to convert or how to round off numbers to the nearest decimal places. So here I'll convert to 2 decimal places, but since 3 here is less than 5, I'll round down to 0 and I'll add my 0 here. So my final answer here is 0.83. That's my final answer. So I have succeeded in converting 5/6 to a decimal number, which is 0.83. Let's look at the next number, 5/7. So for 5/7 again, I'll draw my dividing line and I have my 5 inside the dividing line and 7 outside. 5 is the numerator and 7 is the denominator. Again, 7 into 5 is not possible, so I'll write 0 and I'll put my point here. As I'm putting my point here, my point is being accompanied by a 0 here, so this makes the number here to be 50. How many times can 7 go into 50? It will go 7 times. 7 times 7 is 49. I'll take away, so you see the pattern. First, I will divide. After dividing, I will multiply. And after multiplying, I will subtract. Then I will bring down. So I'll subtract and I'll get what? 50 take away 49, and that's 1. 7 cannot go into 1. So what will I do? I'll add my 0 here because I already have a decimal point here. 7 into 10 is 1. 1 times 7 is 7. Again, I'll subtract and I'll have 3 here. Now, 7 into 3 is not possible. So, since I have my decimal point here, I'll just write another 0 here. 7 into 30 is 4. 4 times 7 is 28. So I'll keep getting remainders like this. So I'll choose to stop here. Again, I'll round to the nearest 2 decimal places. 4 here is not up to 5. So I'll round down to 0 and I'll add my 0 to 1. So what will be my final answer here? 0.71. That's my final answer to the nearest 2 decimal places. So this is a mixed fraction. So for this mixed fraction, you'll keep your 4 in your cooler to be cooling off, right? So what you do now is to use your dividing line to divide, put 1 inside and 12 outside. Can 12 go into 1? It's not possible. So what will you do? You write your 0 and you put your point. And as you are putting your point is being accompanied by a 0. So you add your 0 to the dividend. 12 can still not go into 10. 12 will go into 10 0 times. 0 times 12 is 0. Then you subtract and you get your 10. 12 cannot go into 10, but you already have a decimal point there. So what will you do? You add another 0 here, right? So what are we going to do now? You're going to divide 100 by 12, which is 8. 8 times 12 is 96. So now you will subtract. After subtracting, you will get 4. Now, 12 cannot go into 4. What am I expected to do? I'm expected to add a 0 here because I already have a point here. 12 into 40 is what? Is 3. 3 times 12 is 36. Again, I'll subtract 40, take away 36 is 4. I'll add my 0 again, and now I will now have reoccurring decimals because I'll keep getting 333. Let's try and see. 12 into 40 is 3. 3 times 12 is 36. I'll subtract and I'll get 4 again. So I'll stop there and I can round this to the nearest 3 decimal places if I want. So 1, 2, 3. On the fourth one, you take your judgment. And my judgment here will be 0. I'll add my 0 to 3 here. And what will be my final answer? 0.0 8 and 3. But remember that we have a whole number here. So what happens to that whole number? You bring it down here to 0 and you add, because this 0 is actually the whole number. So if you add this, you have points 0, 0 and 0. So what will you eventually get? You get 4.08 and 3. And that's our final answer. You can do this. You can solve the fourth one and you leave your answer again in the comment section. Now let us go to the most interesting part of the day, and that's what problems in decimal. The first question here is to express 15 kobo as a decimal of 3 naira. Now you take note of this off here and also take notes of the units. Whenever you're doing this, both units must be the same. So here we have kobo and here we have naira. So conveniently, you can convert this naira to kobo. So the relationship is for every 1 naira, you have 100 kobo. Or for every 1 pound, you have 100 pence. For every $1, you have 100 cents. So you have to take note of that. So now initially I said you should take note of this off here. Off here simply means it's going down. Number 1, that is your denominator. So if 1 naira is equal to 100 kobo, then 3 naira is equal to 300 kobo. So 300 goes down here, right? And now we have 15 as the numerator. Now 3 can go into 15 here to give you 5, and 3 can go into 300 to give you 100. 5 over 100, your point is here, so it will move backwards 1 and 2. So inside the curve, you replace the curve with a 0 and you hold your point with a 0 there. And our final answer here is 0.05. Let's try this another way. So we have 15 over 300. 5 here is 3 and 5 into 300 is 60. 3 here is 1 and 3 into 60 is 20. So I have 1 over 20. But I've been asked to express as decimal. So 1 will go into the box while 20 will be outside. 20 into 1 is 0. You accompany your decimal point with another 0. 20 into 10 is not possible. You write your 0. 0 times 20 is 0. You subtract and you get 10. Now you now have 10. 20 into 10 is not possible. Since I have my decimal point here, I'm going to write my 0 here. 20 into 100 is 5. 5 times 20 is 100. So that's our final answer. Number 2, express 15 meters as a fraction of 1 kilometer. Now here we have meter and kilometer, different units. So we are expected to convert one of the units to the other just to make the units the same. So in this case, we have for every 1,000 meters, we have 1 kilometer. So in this case, we have 1,000 here. So, and we have off here, remember the off, right? So here, number 2, we have 1000, and here we have 15. So here we can just divide and get our answers here, because we have 1 and 3 zeros here. So our point is here. How many times are we moving our point backwards? We are moving 3 times, because here are 3 zeros as the denominator. I'll replace my curve with a 0, and I have 0.01 and 5. Let us look at number 3. We've been asked to express 3 days as a decimal of 1 week. Here we have days and week. What's the relationship between days and week? There are 7 days in 1 week. So here we have 7 days. 7 days. So here we have off here. And since we have off there, so what are we expected to do? We have number 3 here. Off goes down. So we have 7 here and 3 stays up. Because of the off, 7 goes down. So we now have our dividing line, and 3, the numerator goes in, the denominator is out. 7 into 3, is it possible? Not possible. I'll write my 0 here and I'll put my point. And my point is always accompanied by a 0. So I have 0 here. 7 into 30 is 4. 4 times 7 is 28. I'll subtract. Remember the pattern, right? First, I'll divide. After dividing, I'll multiply. After multiplying, then I'll subtract. So 30 take away 28 is what? 2. And since I have my decimal point here, just add my 0 here and continue my business. 7 into 20 is 2. 2 times 7 is 14. Again, I'll subtract and I'll get 6 here. Since I have my decimal point here, I'll just add my 0 here. 7 into 60, I'll get 8. And 8 times 7 is 56. I'll subtract, then I'll get 4. Again, I have my decimal point here. I'll add my 0. 7 into 40, I'll get 5. And 5 times 7 is 35. Okay, so I'll now have unending decimals. So in that case, I can just stop here and I'll round to the nearest 3 decimal place. Here we have 5. Since 5 is up to 5, what will I do? I'll round up to 1 and I'll add to the number next to 5. And that will now give us 0.42 and 9. And number 4, what decimal of 1 hour is 20 minutes? Of 1 hour is 20 minutes. Off, remember, this goes down. So what is the relationship between hours and minutes? We have 1 hour. For every 1 hour, the relationship with it is 60 minutes. So at this point, I believe you can solve this and write your answer in the comment section. And this brings us to the end of this class. What have we learned today? We have successfully learned how to convert decimals to fractions and how to convert fractions to decimals. Thank you very much for your time. If you are still watching us and you are yet to subscribe to our channel, kindly do that. And don't forget to turn on the notification bell so that whenever we drop exciting videos like this, you will be the first to get it. Bye for now.